Dear students, in present video lecture, I am going to discuss on topic outer sphere type reactions of M.Sc second semester chemistry, paper P-CH-07 unit 1. These are some points to be discussed to understand the topic electron transfer in inorganic compound, redox reaction, factors that influence, hinders and facilitate the electron transfer reaction, outer sphere reaction, their types, explanation of outer sphere reactions by various mechanisms, conclusions, conditions for outer sphere reactions to be very fast. Now come to the point electron transfer in inorganic compound. Any chemical reaction in which oxidation number of molecule, atom or ion change by gaining or losing an electron known as oxidation reduction reactions. Electron transfer reactions are of several types like electron transfer between two different transitional metal ions in solution and electron exchange between two oxidation states of single elements in aqueous solution. Redox reaction involves either one or two electron transfer reactions, atom transfer of group transfer reactions, electron transfer between two transition metal ions, and electron exchange between single element in different oxidation state. Now come to the point, the factors that influence the rate of electron transfer. Stereochemistry of metal ions, that is the coordination number of metal ion and nature of ligand, charge and electronic configuration of metal ion, availability of the orbitals for electron exchange, and the increase in amount of negative free energy, overall reaction increase rate of the electron transfer. Factors that hinders the rate of electron transfers are the solvent molecules that are around the exchange particles and the ligands that are attached to the ions, particularly effective shielding, the orbital extension in space, and the non-identical bonding of ligand to the metal ions that hinders the rate of electron transfer. Now come to the points, the factor that facilitate the electron transfer. Electronic exchange takes place with is when two exchanging particles have nearly identical structural and electronic configurations. If their configurations are non-identical, then they are made identical with respect to everything except the exchanging electrons by providing energy through thermal motion. And the two ions should have identical spin states except for the transferring electron. If there is overall change in spin state due to electron exchange, then the reaction proceeds very slowly since such transition quantum is mechanically forbidden. In redox reaction, an intermediate have both inner and outer coordination sphere of metal ions. Redox reaction of coordination complexes proceed by the two different type reactions, inner sphere type reactions and outer sphere type reactions. Let's see the point outer sphere type reaction. The outer sphere type reaction is proposed to be operative when both the electron exchange partners are inert to substitution but with slow rapid rates of electron exchange. In this reaction, electron transfer occurs through space. Outer sphere type reaction is very much related to electron tunneling. The coordination sphere of metals stay intact. Only the oxidation state of complexes gets changed, oxidized or may be reduced. The outer sphere type reactions are of two types. First one is homonuclear electron transfer reaction. In homonuclear electron transfer reaction, electron transfer occurs in between two similar metal complexes. In given example, the one electron transfer from hexa-aquo labeled iron 2 plus complex to hexa-aquo iron 3 plus complex and give the product hexa-aquo iron labeled 3 plus complex and hexa-aquo iron 2 plus complex. Here the after one electron donation, iron 2 plus complex gets oxidized to iron 3 plus complex. It means the iron gets oxidized to plus 2 oxidation state to plus 3 oxidation state. In another reaction, the one electron transfer from cobalt to radioactive labeled cobalt to 3 plus complex. Here also the cobalt oxidation state change from +2 oxidation state to +3 oxidation state. In this reaction, the electron exchange obtained in between same metal ion, therefore it also known as self-exchange reactions. Another type of outer sphere reaction is heteronuclear electron transfer reaction or cross reaction. In cross reaction, the electron transfer occurs in between two different metal complexes. In given example, you can see the hexacyano-iron 4- complex when react with hexachloroiridium 2- complex and form hexacyano-iron 3- complex and hexachloroiron 3- complex. Here the electron transfer obtained in between iron and iridium metal. After one electron donation, iron 2+ gets oxidized into iron 3+. Another example, you can see the hexacyano-iron 4- complex reacts with octacyano-molybdenum 3- complex and give product hexacyano-iron 3- complex and octacyano-molybdenum 4- complex. In this complex also one electron exchange from iron to molybdenum and iron gets oxidized to +2 form to +3 form. Whether the reaction proceeds fast or slower can be determined by rate constants. Here rate constants of some reactions has been given. Tris dipyridine iron 2+ complex after electron transfer forms iron 3+ complex. In second reaction, hexacyano manganese 3- complex after electron transfer get converts to 4- complex and hexachloroiridium 2- complex give product hexachloroiridium 3 complex. The rate constants of these three reactions are in between 10 to power 4 to 10 to power 6 liter per mole per second. It is very high, means the reaction will be very fast. In next reaction, hexacyano-iron 3- complex after electron transfer gets converts into hexacyano-iron 2- complex and rate is 7.4 into 10 to power 2, means reaction is fast. In next reaction, manganese complex converts into manganese 2- complex. Here also you can see rate 3 into 10 to power 3, means reaction is fast. In another reaction, tris ethylene diamine cobalt 2+ complex gets converts into cobalt 3+ complex. The reaction is very slow because here the rate constant of reaction is 10 to power -6 liter per mole per second. Thus the reaction proceeds fast or slow, it depends on the rate constant. The third mechanism to explain outer sphere reaction is given by R. Marcus. According to R. Marcus, the solvent and ligands produce an electronic energy barrier that the transferring electron must penetrate for an optimum distance of 6 epsilon. The exchange rate is at a maximum. Here you can see the various mechanism has been proposed to explain the outer sphere reaction mechanism. According to George and Irwin, electron exchange may be rapid for chemically non-identical pair and inert partners provided reactions are thermodynamically favored. In this reaction you can see the electron transfer occurs in between iron 2 complex to lithium 3 complex. Here the both complex have different metal ions. So the electron transfer occurs in between two non-identical pair and the rate of reaction is very high, 10 to power 5 liter per mole per second, and it can say that cross reaction are faster than that of self-exchange reactions. According to Frank quantum principle, the electronic motions is much faster as compared to nuclear motion and electron transfer occurs without appreciable movement of atom. The Frank quantum principle states the following step. If the oxidation state of metal ions change the atomic distance between metal ion and ligand also changed. The recognition of metal ligand distance for reactant and product occurs before electron transfer takes place. In second step, if electron transfer step is rapid, the overall rate is that at which the ion diffuse together to form an ion pair. Here you can see the hexa-aquo-ruthenium 3 plus complex reacts with hexa-aquo-ruthenium 2 plus complex and form a ion pair of hexa-aquo-ruthenium 3 plus complex and hexa-aquo-ruthenium 2 plus complex. And in third step, bond steps around each metal change to become more product-like. The solvent cell amount the outer sphere recognize itself, and in fifth step, electron transfer from reduced species to oxidized species will be very much faster. And finally, the ion pair dissociate to give product. In a graph, there is an energy barrier which depends on activation energy EA and Gibbs free energy delta G. If the delta G is more negative, then the value of activation energy will be low, means energy barrier will shorter and reaction can proceed fast and reactant can easily convert into product. And if the energy barrier will be larger, means metal ligand bond distance larger, the rate of reaction will be low and reaction proceeds slow. After understanding various mechanisms of outer sphere type reaction, we can conclude the topic with few points. If bond distance is more similar and no spin change required, the reaction proceeds very fast. Otherwise, reaction will be slow. Consider electron transfer within hexaamino cobalt 2 plus complex to cobalt 3 plus complex. Here, the bond length of cobalt 2 plus is 2.11 epsilon and cobalt 3 plus is 1.96 epsilon. Means more difference in bond length. And here also the cobalt 2 plus is high spin with D7 configuration and cobalt 3 plus is low spin with D6 configuration. Thus spin change also required. Thus the rate constant is very low, is equal to 10 to power minus 6 liter per mole per second. Thus the reaction proceed very slow. In another case, tris bipyridine iron 2 plus complex and 3 plus complex where the Fe2 plus state with low spin D6 configuration and Fe3 plus state is low spin with D5 configuration, and the bond length of Fe2 plus state is 1.97 epsilon and Fe3 plus state is 1.96 epsilon. Means here the bond length is similar and both the complexes are in low spin, and the rate constant is very high, more than 10 to power 6 liter per mole per second, means the reaction proceed very fast. The another thing which affected or facilitate the rate of reaction is presence of pi bonding ligand. See here the trisphenolphthalein cobalt 2 plus complex. Here the pi bonding ligand present, the rate is very high, 40 liter per mole per second. And in case of hexaamino cobalt 2 plus and 3 plus complex, here the pi bonding ligand absent, the rate is very low, 10 to power minus 6 liter per mole per second. It means the reaction proceeds slow. According to Frank Condom, reaction proceeds very fast when reactants are distorted to appropriate geometry for the product. Reactants will require product-like energy and the bond length of reactants are equal. It means the participating reactants have same electronic orbital and metal ligand bond length. When hexa-aquo-iron 2 plus complex react with hexa-aquo-iron 3 plus complex and give product require very high energy of activation, 33 kilojoule per mole. It is due to, here you can see both the reactants are similar, but iron 2 plus complex has shorter bond length than iron 3 plus complex. Thus, for rearrangement of metal ligand bond distance, high energy of activation required for completion of reaction. Thus, conditions required for outer sphere reactions to be very fast are The complexes of both metal ions or one of them should be inert with saturated coordination cell. The polarization power of the central metal ion should be high. The cross reactions are faster than the self-exchange reaction. Electronic spin of two interacting metal ions must be equal. If the spin stayed same, the bond distance is more similar and energy change will shorter, then the reaction proceeds fast. The complex should have pi acceptor ligand like cyano group, bipyridine group, phenolphthalein group, etc. Reaction should be spin allowed and the electron transfer is likely to be fast if the electrons are able to reach the surface of the complex. So, it's all about the outer sphere type reaction. Thank you for watching